Total Quality Management. In this unit, we will discuss the elements of total quality management. First, we will define quality and then consider various quality programs. These include continuous improvement and Six Sigma. We will discuss benchmarking of internal and external partners to learn from others. We will discuss just-in-time methods and how they support our quality goals. Various tools used to implement quality programs will be covered, along with the implementation of quality methods within a service business. Quality is based on the customer's viewpoint. Products and services are delivered that meet and exceed customer expectations. All actions must directly or indirectly support these goals. Here are some dimensions of quality for a laptop computer. Starting with the customer view, we list the various capabilities of the computer. Note that some requirements are specific to the physical product, while others are related to the services provided in support of the customer experience. These include handoff, help desk, technical support, and repair. From an operations viewpoint, key metrics include cycle time, yield, cost, manufacturability, supplier performance, and logistics. Finally, we consider society's view of the environmental impact of the creation and use of the computer. Total Quality Management, or TQM, is an all-encompassing method covering all aspects of the operation from supplier to customer. The result is an all-inclusive drive to eliminate defects and improve processes. This is not just a product view, but includes all aspects of the customer experience, including sales, billing, and service. The elements of TQM are listed here. Note that this approach incorporates a number of well-known methods, including Six Sigma, benchmarking, just-in-time, and a variety of tools. We don't always consider just-in-time to be a quality-driven approach, but more of an inventory reduction and cycle time improvement method. The quality impact of JIT will be discussed to explain its inclusion. Continuous improvement uses small, continuous steps to improve processes, to eliminate defects, cut waste, and improve cycle time. The principles of Kaizen are applied to all aspects of the business. Every process should be better tomorrow than it is today. Statistically, Six Sigma is defined as a product or process generating fewer than 3.4 defects per million opportunities, and includes a program designed to reduce defects, lower costs, and save time to ultimately improve customer satisfaction. This diagram of a normal curve shows the impact of Six Sigma. Designs traditionally used plus or minus 3 sigma. The delta can be up to 2,700 defects per million. Moving to Six Sigma makes a huge difference. The elements of the DMAIC process are shown here. We start by defining the specific goals and scope of the project. The process is measured, then this data is analyzed. Using the analysis, improvements are made to existing designs and processes. Finally, the process is controlled to make sure that the changes are maintained. Now the DMAIC process starts again. Another method common to Six Sigma is benchmarking. The goal is to identify specific processes within the organization and seek information about the best-in-class methods used elsewhere that may be adopted. The sources for this information may be internal or external. One approach is to seek out companies who are not competitors yet have similar processes. These companies are certainly more open to sharing information than a competitor might be. Surprisingly, just-in-time systems are included in Six Sigma methods. The goal is to establish a pull system where items are produced by need rather than forecast. The result is reduced inventory levels. Processes, products, and operational costs all improve. Taguchi principles are applied to product and process design with the goal of uniformity despite variability in the materials and processes. Next, we look at the tools used to support total quality management. These tools are used for brainstorming, data analysis, and identifying problems. Each of these tools will be discussed in further detail. The first tool is the checklist. This is a tool used to collect data regarding a product or process. This example is a tick sheet capturing defects by type over time. The scatter diagram, our second tool, tracks the value of one variable versus another. Here we see that reduced absenteeism results in increased productivity. The cause and effect diagram is also known as the fishbone or Ishikawa diagram. The tool is used to identify different causes for a given effect. This is often considered to be a tool to facilitate brainstorming. The four primary causes are broken down into materials, methods, manpower, and machinery. You may use different groupings based upon the specific application. Here's an example of a completed cause and effect diagram identifying the causes of missed free throws in basketball. Notice that multiple potential causes have been identified for each major category. Each has been tailored to this example. The next tool is the Pareto Chart. This chart organizes problems in decreasing frequency. In this case, issue A is the most frequent, so it starts to the left, followed by the next most frequent issue, B. While not always the case, the 80-20 rule often applies. This means that 20% of the items account for 80% of the frequency. This chart is useful when identifying the critical few versus the trivial many issues. Since resources are typically limited, it is best to focus on repairing those items with the greatest impact. Here's an example of a Pareto chart of complaints at a hotel. We start with room service at the left with 72% of the complaints. If we can resolve the room service issues, we will have a greater impact than if we had resolved all of the other issues. In practice, we would take action to resolve the room service issues. Once fixes have been implemented and the process stabilized, we would collect the data again to identify the next action item. The flow chart or process diagram is used to diagram the steps in a process and their relationship. This tool is useful when reviewing existing processes or designing new processes. The chart identifies dependencies and is the basis for cycle time and capacity analysis. This flowchart reviews the steps in the process of completing an MRI for a patient. Magnetic resonance imaging is used to detect medical issues within patients, such as tumors, certain heart conditions, and orthopedic issues. The process starts with scheduling and patient preparation. After the scan is completed, there is one decision point, the diamond at step 7, where the decision is made as to the quality of the scan. 80% of the time the scan is good and is passed on to the radiologist, who reports the results to the patient's physician. The next tool is the histogram. The histogram is a distribution of the frequency of occurrences of a variable. The pattern shown is typical, with a distribution that is similar to a normal curve. Given enough data, many processes approach the normal distribution. That is why the normal distribution is used to model so many business processes. The statistical process control chart is used to track actual results for a process. The goal is to define when corrective action is needed to keep the process under control. The upper and lower control limits identify the points where the process will no longer be in control. We use statistical control charts to manage a process. We are looking for out-of-compliance points. In the previous chart, the fifth and last data points. We also watch for trends so that proactive corrective action may be taken before defects are created. This data provides the opportunity to improve the process and immediately see the results from our effort. We continue to monitor the process to ensure compliance and react to future variants as needed. Here's an example of an SPC chart applied to basketball free throws. The metric is the number of free throws missed. Obviously, there is no such thing as too few misses, so the lower control limit is 0. The coach has decided that greater than 40% misses calls for action. The next topic is inspection. An employee checks for the function of a product and sets it aside for repair or disposal if not to specification. The inspection itself does not fix the process variation that caused the defect, but it does help us identify when there is an issue that needs correcting. Inspection is expensive and it does not always catch all of the defects. Defective products that pass inspection are often called escaping defects. Opaoke is a method to create test fixtures and devices to quickly and accurately check the function of a product so that acceptable product moves forward in the process. Examples of fail-safing are shown here. Classic go-no-go gauges in the tooling industry are well known. Examples that we see every day include three-pronged electrical plugs. They can only be inserted into the outlet one way, the correct way. Additionally, USB connectors only go in one way. Management of quality within a service business can be more difficult since quality is often an eye of the beholder issue. The customer's view of product acceptance may have intangible factors that vary from customer to customer. I'll know it when I see it. The service recovery process is designed to address failures and is often customized for each situation and can be very fluid based upon the issue and the customer's response. In this example, the team at Alaska Airlines has a number of performance specifications for the operation. For airlines, an airplane on the ground is not making money. We see that the specifications support an overall goal of getting the airplane ready for takeoff on time to prevent delays. Each has a time element within the measurement. There are many factors that drive the outcomes of a service. To achieve top levels of customer satisfaction, these determinants are often closely managed. Looking at the list, consistency, competence, communication, and understanding are some of the goals. Note that these goals are somewhat intangible and may be difficult to quantify. There are some tangible aspects to consider, but these are only a small part of guaranteeing a positive customer experience. Key points to remember: the elements of total quality management. We defined quality as primarily a customer view with additional operations and society views. We broke down the key elements of total quality management, starting with continuous improvement. The Kaizen methods seek to make quality better tomorrow than it is today by improving methods, materials, and training. Six Sigma is a program that pushes processes to achieve fewer than 3.4 defects per million opportunities. The DMAIC approach is used to define the goals, measure the process, analyze the data, improve the process, and control the updated process. Benchmarking is used to find best practices internally and externally. Just-in-time methods require optimized processes to be successful. The tools used to implement quality programs include the check sheet, which is simply an organized way to collect data. Scatter diagrams graph the raw data points of one variable versus another. A fishbone or cause and effect diagram is used as a brainstorming tool to identify the potential causes for a given effect. Causes are grouped by man, machine, materials, and methods, although other categories may be used. A Pareto diagram is used to identify the critical few versus the trivial many. By organizing data by frequency, we often find that 20% of the causes create 80% of the problems. Flowcharts are used to document and analyze a process flow. Histograms graph the frequency of events, often resulting in a normal distribution. Process control charts establish process limits to identify when a process is out of control. Opaoke techniques add methods that are fail-safe. Finally, quality methods are applied to services where the key may be the customer interaction, which can be tangible or intangible.